Okay, we're going to talk about S10H.2 rational exponents. And so the key thing that we're going to talk about right now, so if I've got something time with, so if I've got like 2 squared times 2 cubed, just the rules of exponents is that you add those powers. This is 2. And then so that becomes 2 to the 5th power. And one way I could prove that or show that is we know that 2 squared is 4, right? And we know that 2 cubed is 8, and 4 times 8 is 32. And what is 2 to the 5th power? 2 to the power 5 is also 32. So the power the laws say that if I got a number to a certain power times that same number to the certain power, you just add the exponents. So here we've got a to the 1/2 power times a to the 1/2 power. We're going to add those powers, the 1/2 and the 1/2, to get a to the 1 power, which is simply a. Now, if I've got square root of a times square root of a, we know that that is equal to the square root of a squared, which is also simply equal to a. So the thing that we're trying to show and prove right now is that if I've got a power of 1/2 plus a power of 1/2, and that gets me this power 1, we can, and this also gives me a. What we're trying to show is that we can rewrite a to the power of 1/2 is the same thing as the square root of a. Also, in the same way, a to the power of 1/3 is the same thing as the cube root of a. So we're going to use this knowledge to help us solve the problems that we're going to work with today. Also here, if I have a with the root n to the power of m, we can write this as a to the power of m over n. So let's just do some examples to start off with. Okay, so the first one here, so write as a single power. So if I've got the little 3 here, this means this is 2 to the 1/3 power. Okay. The next one, 1 over the square root of 2. So up here we just said the square root of 2 is the same thing as to the 1/2 power. So I'm just rewriting the square root of 2 as 2 to the 1/2 power. And now if I've got something in the denominator and I want to bring it to the numerator, then you simply make the power negative. Okay, let's look at one more. So I've got 4 with to the root of 5. So first off, I think of 4 is, so we have 4 to the 1/5 power. And we also know that 4 is 2 squared, right? So if I've got a power to a power, then here you multiply. So 2 times 1/5 is going to give me 2 to the power of 2/5. So let's do a couple more here. So here I've got I've lost my pen. Okay. Here I've got 2 to the 1/5 power. Here I've got 1 over 2 to the 1/5 power, and I can rewrite that as 2 to the negative 1/5 power. Okay, so here I can think of this as 2 to the power of 1 times 2 to the power of 1/2. And we learned up here, if I've got this times this, we just add the powers, right? So if I've got 2 to the power of 1 times 2 to the power of 1/2, that is equal to 2 to the power of 1/2, or let's write it as 3 over 2. 2 to the power of 3 over 2. Okay, here I've got 4, which is 2 squared. And I've got this is 2 to the 1/2 power. So times 2 to the 1/2 power. So this is the same thing as, so we're going to have 2 to the power of 2 plus 1/2, which is equal to 2 to the 5/2 power. And I'm going to put the answers for the rest of these up at the end. So right now, I'm going to do example 2. Okay, without using a calculator, write in simplest form. So the very first thing I do is, okay, we know that 8 is 2 cubed, right? Okay, so if I have a power to a power, we can multiply those values. So 3 times 4/3, well, we know that 3 times 4/3, that 3 in the numerator is going to cancel out, and I'm just simply left with 2 to the 4th power, which is 16. And let's see if that works on the calculator, just to double check. Okay, so if I have 8 to the power of 4/3, did I do it correctly? Dun, da, da, da. I did. So we're trying to understand the power exponential rules, because this is going to help us when we're doing logs and stuff like that. So, so 27 we know is 3 cubed, right? And to the power of negative 2/3. So if I have a power to a power, we can multiply those values. So 3 times negative 2/3, right? This power times this power is going to give us that 3 in the numerator cancels out with the 3 in the denominator, and so that power is going to simply become negative 2. Okay, and so if I've got a negative 2 power, I can write this in the denominator, and now the power becomes positive, and so 1 over 3 squared is going to give me 1/9. Okay, let's do 1 or 2 more here. So I've got 4, which we know is 2 squared, and then here we multiply those powers together. 2 times 3 over 2 is just going to simplify to 3. Okay, so I'll put up the answers for those in just a minute. So now we're going to do example 3. Okay, so what I can do here, let me zoom in so you can see this a little better. I can do distributive property to each of these. Okay, and so we know that, so we're going to have x to the negative 1/2 times x to the 3/2, so we're going to have x to the negative 1/2, so we're going to add those powers, plus 2 times x to the negative 1/2, we're going to add that power, plus 1/2, then minus 3 x to the negative 1/2 times x, so we're going to add that power. Okay. Okay. So when you multiply x to this power times x to that power, we add the powers using the laws that we just talked about a little bit ago. So negative 1/2 plus 3/2 is going to give me x to the power of 1. X to the negative 1/2 plus x to the 1/2 is going to give me x to the 0 power. And x to the negative 1/2 plus the negative 1/2. So we're going to have x to the negative negative 1/2, and negative 1/2 is 1. Okay, so this simplifies to x plus 2 minus 3 over x. The only thing to the negative power is the x here. Okay, let's do a couple more together here. So I could write this as x to the 1/2 minus 1/2 here. So, and then this gives me x to the 0, which is equal to 1. Here I have x to the 3 halves, and then minus 1 half. That is equal to 3 halves minus 1 half is going to give me x to the power of 1. Let's do C. X squared. So I have x squared minus 3 halves. So 2 minus 3 halves is going to give me x to the 1 half power. And I could rewrite that as the square root of x. Either of these answers is fine. I don't care. Okay. Let's do one more example here. And then, okay, so that power needs to get multiplied. So we have x squared times x cubed gives me x to the 5th, plus x squared times 2x squared gives me 2x to the 4th, and x squared times 1 gives me x squared. Okay, 2 to the x times 2 to the x is going to give me 2. Remember, we add those powers, x plus x, right? Plus, and then 2 to the x times 1 is 2 to the x. So this is going to simplify to 2 to the 2x power plus 2x. Okay. Let's do one more. X to the 1 half times x to the 1 half is going to give me x to the 1 half plus 1 half there. Adding those powers together. And then x to the 1 half times x to the negative 1 half. We're going to add those powers together. Okay, and this is going to simplify to x to the power of 1 plus x to the power of 0, which is just x plus 1. Okay, so okay, this is kind of fun. Okay, so x to the 2 to the x times 2 to the x gives me 2 to the 2x power. 2 to the x times 1 gives me 2 to the x. 3 times 2 to the x is 3 times 2 to the x, and then plus 3. Okay, so we've got a like term here. So let's call this 1 times 2 to the x plus 3 times 2 to the x. That's going to give me 4 times 2 to the x. Okay. And then 4 can be written as 2 squared, right? So I can simplify this as 2 to the 2x plus 2 to the x plus 2, and plus 3. Okay, so because this is plus, we can't combine those values there. Okay, I want you to try these on your own. I'll put up the answers in a minute. Okay. Here I've got this is 2 to the n times 2 cubed, and this is plus 2 to the n. And then I can see I've got something I can factor out. I can factor out 2 to the n. So using distributive property, I can write this as 2 to the n times 2 cubed plus 1. Because this is 2 to the n times 1, right? I've factored out 2 to the n. hit pause if you need to think about that for a minute. Okay, so we're almost done. We got 2 to the n times, okay, 2 cubed is 8, right? 8 plus 1 is 9. So I've got 9 times 2 to the n. Okay, this one here is 2 to the n times 2 cubed plus 8. Well, we know 2 cubed is 8, so I've got 2 to the n times 8 plus, let's just call this 8 times 1, just so we can see that we're going to use distributive property, and we're going to factor out the 8. And using distributive property, then we have 2 to the n plus 1. And that's factorized. Okay. We'll do one more of this style. And we've got 2. Okay, so notice the bases are the same. So now I can add these powers, 2 to the 3n, and add that power 2n. And that's going to simplify to 2 to the 5n. Okay, so I will put the answers to these other ones up in just a minute. Okay, let's do example 6, factorized. Okay, so what you're supposed to recognize is that this is difference of squares, right? So if I've got a squared minus b squared, this gives me a plus b times a minus b. We have difference of squares. But instead of a, we've got 4. So we can think of this as 2 to the x squared minus 3 squared, right? So instead of a, I've got 2 to the x. Instead of b, I've got 3. So now I can write this as 2 to the x plus 3 times 2 to the x minus 3. Okay. This question 2 here, let's think of this as 3 to the x squared plus 4 times 3 to the x plus 4. So I think the easiest way to do this one is, let's just think of this as I'm going to let 3 to the x equal, let's call it w, right? So if I've got w squared plus 4w plus 4, how does that factor out? So what two things multiply to give me 4 and add up to give me 4? And that's 2 times 2 gives me 4. And if I put plus and plus. So now I can rewrite this, but instead of writing w, I'm going to write x cubed. So we're going to, 3 to the x. So we have 3 to the x plus 2 times 3 to the x plus 2. And that is the answer for that one. So this is a really good example. I'll put up the answers in just a minute. Okay, the last new type of question is this here. So if I've got 6 to the n, we can think of this as 2 to the n power times 3 to the n power over 3 to the n power. And then we can say, okay, the 3 to the n cancels out on the top and the bottom, and we're simply left with 2 to the n power. Okay, let's do this one here. If I've got 4 to the n, that's the same thing as 2 to the n times 2 to the n over 2 to the n times 3 to the n. And then we can say, okay, this 2 to the n and that 2 to the n are going to cancel out. And then we're simply left with 2 to the n over 3 to the n. Okay. Okay, last new type of question is I can do some distributive property in the numerator, and I can say, okay, so this numerator is going to become 3 to the n. Okay, the 6 to the n, I'm going to rewrite it as 2 to the n times 3 to the n. So I've got 3 to the n plus 3 to the n times 2 to the n over 3 to the n. And we can see quickly that if I did distributive property, I would have 3 to the n with 1 plus 2 to the n. Right? And this 3 to the n in the numerator and the denominator is going to cancel out, and our final answer is 1 plus 2 to the n. Okay? And I'm just going to show you the answers for everything else. So back to the first page. Here are the answers. You're going to want to hit pause, and when you get to them, you can check your answers. Hit pause. Okay. Now for these, check your answers and hit pause. Okay. Now check your answers and hit pause. Okay, next page. Check your answers and hit pause. Okay. Check your answers and hit pause. I think we did these. Okay. Next page. Check your answers and hit pause. Okay. Hit pause. Alright, check your answers here. And here are the answers for these. Okay. And the last page. Okay, and then hit pause again for the last answers. And there you have it.